They're notes on 9-6. Hooray! Well, last section notes for chapter 9 anyway. Okay, so here's the deal. We have our ax squared plus bx plus c, just like we've been doing. The directions are to factor, just like we've been doing. But I don't know if you have noticed or not, but all of the polynomials, the quadratics that I've been giving you, have had an a that was equal to 1. A has been 1 this whole time, and that has made your life very easy. What will we do if A isn't 1? Because it's not always 1. We've just been focusing on the easy ones. For example, what if I have 5n squared plus 2n minus 3? Previous to this, if there wasn't a 5 there, we would have said what multiplies to negative 3 and adds to 2. But that is only because there was a 1 in front of there, and really what we were doing was what multiplies to 1 times negative 3. We were multiplying that 1 as the a each time, but we just didn't talk about it because it was 1. Now what we need to think about is what multiplies to negative 15 and adds to 2. This can lead to a lot of guessing and checking. So there is a trick, and what I'm going to do is I'm going to show you the trick here. The first thing that you're going to do, and by the way, I've been tipping you off with this trick as we've gone along, but the first thing you do is the first term, the 5n squared, goes in the top left box. The last term goes in the bottom right box. Then that's when you talk about what I was just mentioning was what multiplies to negative 15 and adds to 2. But you have to include the variables now. So it says step 2. We know we have the middle term of the polynomial has an n, so the other two boxes must have some kind of n, okay? N times n is n squared. That's how we're getting that, okay? So what we're saying, I'm going to rewrite the equation right here. 5n squared plus 2n minus 3. We have the 5n squared, we have the negative 3, and I want to say what multiplies to negative 15n squared. We include the variables now. And what adds to 2n. Okay, so that's why the n's are there, because something plus something in the n's is going to be 2n, and n times n is n squared. So what are some factors here? Well, there's factors of 15 of 5 and 3, and we just have to have the right combination. So we know it's going to be a negative, one negative, and one positive. And if we have 3 and negative 5, that's negative 15, but it adds to negative 2. If we have negative 3 and 5, that multiplies to negative 15, but it adds to 2. So we know that this is our magic combination here. It's going to be a negative 3n and a 5n. They multiply together to get negative 15n squared, and they add together to get a positive 2n. So those on the next page have now been plugged in. It does not matter if the 5n went here or the negative 3 went there. Okay? All right, so now that we have plugged them into the two missing squares, we have columns and we have rows. And we're going to take the GCF, the greatest common factor of the columns and the rows. And that's done in the next one. So in row 1, this is row 1, the GCF is 5n. They each have a 5n, it comes out. In row 2, the GCF is negative 3. And remember we talked about right here, this door cannot have a negative number touching it, so the negative had to come out. In column 1, the GCF is just n. And in column 2, there's no GCF except for 1. Now you may say, hey, there's a negative there, but this door where it's going to go out, it doesn't have a negative, so that's okay. The leftovers, the GCFs, are the two factors. So we have 5n minus 3 and n plus 1. If I FOIL these out, I get 5n squared plus 5n minus 3n plus negative 3, which is 5n squared plus 2n minus 3, which was my original polynomial, my original trinomial. Okay, oops, I need to scooch it up there. There we go. Okay, so basically the message after you have your two factors, FOIL it out, make sure that it works. So we're going to practice these on the next page. Okay, so we have in this one 2x squared minus 11x plus 5. So make your 4 square. First term is a 2x squared. It goes in the top left. 5 goes in the bottom right. Now we say what multiplies to this term times this term. So that would be 10x squared. So what two things are going to multiply to get 10x squared and add to get a negative 11x? All right, so it's going to be negative 10x and negative 1x. They multiply together to get a positive 10x squared. They add together to get negative 11x. It doesn't matter which one you put where. And now we're going to factor our columns and rows. So in column 1, x is my greatest common factor. In column 2, there's a negative touching the door, so he has to come out. And then 5 is the greatest common factor. In this one, 2x is the greatest common factor. There's not a negative touching the door, so it stays in. This one does have a negative, and 1 is the greatest common factor, so negative 1 comes out. That means I am left with, as my two factors, x minus 5 and 2x minus 1. If I FOIL it out, I get 2x squared minus x minus 10x plus 5, which is equal to 2x squared minus 11x plus 5. I highly recommend you do a check each time. Okay, now the next example is slightly different because the a term is negative, and that will cause a big problem for us. We, when we're plugging it in, cannot have this first term be a negative or it messes the whole thing up. So how do I get rid of a negative? Well, I factor out a negative. So if I factor out negative 1, now I have 4x squared, but I had to factor it out of each item there, so that becomes minus 4x and minus 3. Now, the biggest thing is that kids are going to forget about this minus 1, so sometimes I'll actually put a circle around it and say, do not forget this guy. He's got to go back in the end. If you don't put him in the end, you're going to have a different equation. Now I'm back to normal, though, for this part. So now we're going to use the 4 square on this trinomial. So I have 4x squared and minus 3. What multiplies to equal these two, so negative 12x squared, and what adds to the middle term, which is negative 4x. Okay, so think about your factors. It's going to be 6 and 2, isn't it? And it's going to be the negative 6x and the positive 2x. Those are going to be my two terms. Doesn't matter where you put them. Factor your columns and rows. So we have 2x minus 3, 2x plus 1. Okay, so now when I rewrite them, it's 2x minus 3 and 2x plus 1. Right there, okay? But remember my guy in green, I can't forget about that negative 1. The negative 1 goes out in front, okay? If you had the negative guy in here, it would not be factored completely, which is what we learned in the last section. Okay, now to check it, this negative 1 just gets multiplied by one of these terms. You don't distribute it to every single thing. For example, let me just show you. If this was negative 1 times 2 times 3, that's not negative 1 times 2 and then again times 3, right? It's just negative 1 times 2 is negative 2 times 3 is negative 6. It just gets multiplied by one of the terms. But what ends up happening for kids is a lot of times I see them give it to every single item. It just gets multiplied by one thing. The way you can prevent that from happening then is you can actually FOIL out first and then multiply by the negative 1. So I'm going to leave the negative 1 out there and I'm going to FOIL. So I have 4x squared plus 2x minus 6x minus 3, which gives me negative 1 times the quantity of 4x squared minus 4x minus 3, which is what I had right before I factored. And then distributing my negative 1 to each term now gives me negative 4x squared plus 4x plus 3, which was the original problem. All right, so we're going to practice a few. So you're going to actually just pause right now, do number 1 only, and then come back to see how you did. All right, so put the 3x squared here, the 2 here. These could be in either location. You factor out your greatest common factors. I factor out a negative 1 here because there was a negative touching the door, and a negative 2 here because there was a negative touching the door, but they each had a factor of 2. My two common factors are 3x minus 2, and then my other factor is x minus 1. I FOILed it back out to double check that it worked, and it did. Okay, try the next problem. Okay, make sure you've paused the video and done this one. If you haven't, go ahead and do it. So here's what I ended up with. What multiplied to negative 42m squared and adds to 1m, it's 7 and negative 6. I plug them in, and I factor out the greatest common factor. I end up with 2m plus 7 and m minus 3 left over. If you're having trouble, come see Mrs. Wyman. Otherwise, proceed on to the next example and make sure you take note of something that's special about it that we talked about earlier. Go ahead and pause and try it. Okay, so I factored out a negative 1 because my very first term that A term cannot be a negative, so I factored it out. Then I said what multiplies to 10y squared and adds to 11y, it's 10y and 1y. And I notice I put my green circle because when I write my two binomials, I need the negative 1 out in front. Then I'm just going to show you the check to make sure you're doing it right. So I'm going to ignore this negative 1 on the outside for a moment, and I'm going to FOIL these to get 2y squared plus y plus 10y plus 5. Negative 1 still out there. Combine my like terms, and then distribute your negative 1 through. So it's negative 2y squared minus 11y minus 5, which was my original problem. So I'm going to box in my completely factored forms. All right, one last thing we need to discuss in this packet. Example 4 here. We're back to vertical motion model. Hooray! I know you're so excited. All right, so tennis. We have an athlete hits a tennis ball at an initial height of 8 feet and an initial vertical velocity of 62 feet per second. So what you should have just noticed was we have a change in what we've always seen before. Our initial height previously was always what? 0, and now it's not, okay? The vertical motion model should be memorized in your head by now. We're going to need to use this because they give us time, velocity, initial height. Your brain should go, oop, that's vertical motion model. So we're going to use that vertical motion model to solve this problem. Here it is, okay? That's the vertical motion model. If you want us to write it again, there's my abbreviations. Okay, now plug in what you know. H stands for what? Final height? Don't know it. Negative 16t squared deals with the force of gravity. That's always the same. Initial vertical velocity, they told us, was 62 feet per second, and initial height this time is 8. So V was 62 and S was 8. Okay, so that is step A, writing the equation to model the situation. Part B, after how many seconds does the ball hit the ground? If the ball is hitting the ground, you know H is what? That's 0, right? Because H stands for final height. So we are going to substitute 0 in for H, and then we're going to solve our problem. Okay? Now, CA is no longer going to be a nice 1. Before, we just had something we could factor out, and now we have a trinomial, so we can no longer do that. So we substituted 0 for H. Now, some of you may not like that there's equals 0 on the left. You can always put it on the right. Otherwise, I'm just going to keep it over there. You have to factor out the greatest common factor. That's always step 1 in factoring, remember? So the greatest common factoring, we can't have this guy be a negative, so it's negative 2. And we're left with 8t squared plus negative 31t, I factored out a negative, minus 4. So we factored out negative 2. Now we have to factor the trinomial. So over here on the right, go ahead and make your 4 squared, pause the video, and see if you did it correctly. Okay. I hope that you got the factors, 8t plus 1 and t minus 4. What multiplied to negative 32t squared and added to negative 31. So now we have 3 things being set equal to 0. But the first one we can ignore. Negative 2 is never going to equal 0. There's a statement here, negative 2 does not equal 0, so we just get rid of that guy. But this guy could be 0, 8t plus 1 could be 0, or t minus 4 could equal 0. So that's our zero product property. Okay? So this ends up being subtracting 1 dividing by 8, can't squeeze it in. That ends up being a negative 1/8. So t is a negative 1/8, or adding 4 to both sides, t is 4. Well, let's think about that. Can we have a negative solution? Nope, negative solution doesn't make sense. So that guy doesn't work either. I do have to show my work to get him to prove that it's not going to work. So the tennis ball is going to hit the ground after 4 seconds. There's my nice word answer. All right, so we have the same idea up here, but they're changing the information. So you're going to try to do this problem totally on your own. Go ahead and pause it and work it out. Okay, let's check your work. Here's my equation right here. I have to factor out the greatest common factor as my first step, which is negative 2, and I'm left with 8t squared minus 10t minus 3. So I did my 4 square work over here, what multiplied to negative 24t squared and added to negative 10t. I found out that it was 2t and negative 12t. My two factors then are 2t minus 3 and 4t plus 1. The negative 2 is out in front still, and it's set equal to 0. So each item could be 0 except for the negative 2 cannot equal 0. And I solve for t, and I end up with 3/2 or a negative 1/4. You can't have a negative time, so it's going to be 3/2. But you wouldn't say that in a real world problem. You'd probably say something like the ball hit the ground after 1.5 seconds. You're not going to say 3/2 seconds. Okay, that's the end of your notes. Fantastic job on Chapter 9, and we are going to continue on. Go ahead and do your assignment.